Awesome. This is another programming stream. Welcome. I have set some new goals for today that we'll be taking a look at. Last time, actually, let's first look at where we left off last time. Right. So we implemented the depth buffer. We implemented some basic shading. And we implemented this plane that we generated where we can set the resolution of the number of vertices that we're using. Yeah, we also added backface culling, so the back of triangles are not rendered. Yeah, so for this stream, I would really like to implement a height map using that plane that we generated earlier. Then load it in, and then just apply to that plane mesh. Then I would like to get into sRGB textures. Then do some mid mapping and texture filtering so we can get better texture quality. And then do a skybox. And if I still feel like doing some more programming after that, we'll get into some stuff for the water effect that we'd really like to make. So we'll like generate a plane for that. Do some tests with some rays. Do some triangle intersections with arrays. And then do some data stuff where we can actually access triangle data that we upload from the CPU. But let's get started with this first goal. I actually already did a bit for that. So I created this this image, which I'll put in the assets folder, gradients.png. And this is simply a gradient from black to white. And this is going to be great for testing our height map. Since for every pixel, we increment the value by 1. So if I have the color picker here, what you can see over here is that the first one's 0, then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, goes all the way up to 255, which is white. And the way this height map is going to work is black, 0, is going to be a really low point, and white, 255, is going to be a really high point, and everything in between, all this value in between are going to be in between the high and low point. And we want these to be linear. So what I'm really looking for is that there's no curve in there, it's a straight line, just a straight diagonal line. So let's load that in and let's generate a height map and stuff. And I was thinking a bit of where to put this, and I think we should just make it part of the asset system. So I'll just add another function. Test load height map. Now I stored these pixels, I think, as 32 bits, but I think I can store them as 8-bit values. Single components. I'm not sure how I can change that in Paint, in paint.net. I know how to do it in Photoshop, but I don't have Photoshop, since the tool's pretty expensive. Let's look it up. Otherwise, we can generate one in code. Or I have a better plan. We'll just read the first channel and just use that. So we'll say buffer out with out height. All right. Then it's simply loading a texture, but we're going to do some conversion on the texture. So we'll load gradient PNG, and we're expecting 4 components. Actually, wonder what happens if I just say I want 1 component. So let's call this function, so we can step through this. Let's just pass null for all of these. We'll just not use the parameters. Just so we can read this, run this. I wonder what it will do if we pass 1 component. I made a typo. Oh, I forgot semicolon. Let's see what it gives a buffer. It will give us a buffer. So now I'm wondering. Oh, because this is the minimum number of components, and we got 4 components. So we'll just let it take 4 components. So we'll just take the. Let's see. Let's just take the blue value since it's probably ARGB, right? BGR. No, it's RGBA. So it's R, which is in the lowest 8 bits. So we'll take the red channel. Doesn't really matter for grayscale anyway. Yeah. See, got an error. Width simplified. Oh, because it's WMH. Cool. Like that. Then we can actually free that image, and we can output our buffers and sizes and stuff. And gray buffers actually already in the correct format, but this should be pointer to pointer. Cool. So let's add the types to our game memory structure. And now I'm just passing the parameters of all the things we want to output. Cool. Let's see if this should work. Let's see if it crashes or not. And everything still seems fine. Awesome. Let's move on to the next bit then. Let's add a function in our graphics system for uploading this height map. Yeah, that looks fine. And of course, this is going to be a D3D11 function, since it's in our D3D11 code. And there is some stuff that is like not specific to our graphics API that's in here, but I just like writing the code that does stuff, and then write the actual good code if we need it. Awesome. So what we can do now is call a function. This function for generating a plane mesh, which takes number of vertices on the x and y axis. So we'll just pass the width and the height of our height map. Then I want the vertex buffer. No, indices. And the index count. Awesome. So now we can just use the function that we wrote last time. I'll just put these all below each other, under each other. The function we wrote last time to generate a simple plane, and now we can adjust the y value of that plane using the data in our height map. Cool. And then we want vertices y times the width plus x, and we need to multiply by width to basically move down a row, since there are width elements on each row. And then we can say that position dot y is let's see, what is the y position? It will be, let's actually first sample our height map. I will stick this in UN32. So we'll convert this to a floating point value and then divide by 255. That will give us a value between 0 and 1. I will subtract 0.5 from that to have a value between -5 and 5, which will be consistent with how we do the height map. Oh, that's actually -1 and 1, isn't it? Then we'll do that. Also times 2 minus 1. Then we'll adjust our vertices. Then we can upload everything to the GPU. So let's add new vertex buffers. I'll just call this height map PV, height map IV. We can actually get rid of these, so the compiler will tell us what code we need to get rid of. Don't want to get rid of that, we just change that. This we can get rid of for now. And we can actually copy paste what's in here and reuse it. And we can say D3D11 height map vertex counts. Height map vertex counts. So we store it in the right place, and this all becomes height map. Let's call these vertices height map, height map. Height map. We need the H results. Cool. Oh, these are just called the indices. Cool. So that uploads it to the GPU. Height map vertex buffer, height map index buffer. So we bind our new buffers. Height map index count. Cool. Then we'll have to call the function to upload this data. Otherwise, we're just doing nothing. And it seems to not do anything. Let's take a look. So we're not scaling our y-axis as much, so let's uniformly scale this map. I just moved it up, which is sort of what is expected. Well, that's actually, if it moves up, it means the y value wasn't 0. So this definitely changed. Oh, because we're just assigning a half and not height. Haha. That's still a mistake. Now let's actually comment this loop. Apply y values based on the height map buffer to the plane. Whoa, there we go. And we get exactly what I was expecting we would get, which is this this linear slope. Since our height map looks like this, we have low and we have high, so we get low and high. Now let's make a slightly different height map. I could do this at any resolution that we like, since we just use the resolution of the image. Let's first make you 1 to 7, which is going to be 0 once we convert it to floating point. I will just pencil in some pits and some. Actually, we can just do this. Yeah, this will sort of be our height slider. So this is going to be some lower parts. And like Paint.net is really not built for making height maps, so I just want to demonstrate that the height map works, and then perhaps we can find a better height map online. Oh, we'll make this like a high area. Perhaps what I'm thinking is we should draw like really low opacity, and then the more we draw, the more we draw, the brighter it gets. That doesn't really work. Huh, I'm trying to figure out how I can do like a smooth transition. But I doubt this is really going to work. Well, let's just load it and see if we get this like one high point and this deep thing here. Like this one really dark hole. Oh, I wanted a really dark. This one really deep place. And let's have like a little peak over here. Test height map. We can start as 8-bit, like it doesn't matter. There's only 255 different values. And it doesn't have to use any dithering. So now we start really compressed. Even though it's still larger than the last one, but it's... Oh, that's actually funny. Perhaps because it's a gradient? Let's actually see what happens if we start this 32-bit value. I'm wondering. Because the PNG compression might actually work better. No, it is bigger. Perhaps it's just better at compressing a gradient than it is doing our random image. Yeah, let's load the other file. Yeah, we got a really weird height map. So we have like this steep point here. We have our weird tower that we made, and our peak. And it looks really ugly because we don't have any proper tools for this. So let's look for like a free height map online. Free use height map. This already looks great. Can I use this? I don't know. It seems not something like what I want. Free terrain height map. Download a turbo squid. That's a completely random download. Feel free to use however you want, but it doesn't upload the file. Well, the height map code works, so we can always later find a different, better looking height map. I don't really want to bother with that right now. So we've already done our first 3 goals for a height map. So a height map's actually pretty easy. Some interesting things we can improve this upon is to not use 8 bits, an 8-bit height map, but we can actually do a 16-bit height map or even a 32-bit floating point value height map. that we can go completely wild with all the precision that we get. But for testing purposes, 8 bits is plenty. So now let's talk about sRGB. sRGB is actually a surprisingly difficult topic, and I'll have to grab some resources on the screen. Let's see, I have a... Oh, I need to sign in, 1 second. Awesome, I found what I wanted to find. This thing. So sRGB is an RGB color space that HP and Microsoft created cooperatively in 1996 to use in monitor printers and the internet. Basically, sRGB is a way of representing data that lies more closely to how we perceive lighter and darker colors. If we were to store everything standardly linearly, every step in gradient would be exactly the same. But humans we notice changes in darker colors more than in brighter colors. So it makes sense to create some encoding way that would give more precision to darker colors than to lighter colors. And what they come up with is this curve, also called the gamma curve. Let me actually disable a few things here that we don't need. So let's get rid of all the clutter. So as you can see right here, if I plot at a half, you see it outputs 0.214. If I go to height of half, it takes up almost 3/4 of our input data, or like of our input range, is being used up to just represent 0 to 2.5. The other 25% is just for the other half. And all our textures, most of our textures are encoded using this system. And if we are just drawing the image, we don't care about this, because the monitor also expects, I believe, sRGB color. However, if we're doing shading, this messes up colors. So what we need to do is convert this to linear color, then do our shading, and then I believe we have to convert it back to sRGB. Or do some other fancy tone mapping with dynamic gamma. The formula is a bit of a weird one, because as you see, I've plotted this with 2 different colors. There's basically a linear formula for the really small range, and then it goes up into this exponential, well, quadratic formula for the rest of the curve. There's also the inverse of that. So you use this curve to convert to sRGB, and this curve to convert from sRGB to linear. And here I have basically inserted the one function to the other function, which gives you a linear graph to demonstrate that this works. And then there is one more, which is the following, which is using taking the value to the power of 2.2, and this is a really close approximation of the sRGB curve. Like right here, it's not quite correct. Here it intersects at some point, and then it isn't correct anymore. And then it gets really close again. Luckily for us, the hardware, well, the graphics has special hardware for converting between sRGB and linear. And the only thing we have to do is pass some flags. So when we load our texture on the graphics card, when we upload that, upload test texture. For the format, all we have to do is tell it that this is an sRGB texture. That's it. We don't have to do all the math ourselves. It just does it for us. Now the thing I'm wondering about, which I'm actually not sure of, is if we need to output sRGB data as well, or if it expects linear data. I think if we output linear data, that we're good. So to test that, I think we should just disable the shading for now, which you can simply do by setting shading value to 1. And then compare our texture to what it looks like in Paint. That's a bug. When we minimize the window, it tries to resize to swap shape 0 pixels, which it doesn't like. So let's open our texture in Paint. Open. As you can see, that just looks nothing like it. Colors are completely messed up. And if we revert back to just read as if it's linear, let's take a look. We get our picture back. Even though it still doesn't look right. Huh. I wonder why it's so different though. Looks like we have some other bug also going on. This dark green is way darker, and this red is also a lot. Well, this orange looks more like red, it's also darker. Perhaps, let's take a look at the subchain. Perhaps this also wants sRGB. I think for that we need to make this typeless. And when we create the RTV, the render target view, we mark that as sRGB. Doesn't like that at all. It doesn't like typeless. So suppose we can make that just unorm. But that'll probably complain about incompatible types. No, that is actually fine. Yeah, now we're getting the same color as in Paint. That looks about the same. Except now we need to read our texture as sRGB. So let's make this sRGB. And then we'll use that hardware that's built in for doing that. Back at the same result. Now I'm really not sure. So I definitely know that we need to mark the textures as sRGB. It might also be that paint.net just isn't displaying the image correctly. Or it's not sRGB encoding it, which could also be the case. And I have no way of checking that really. Let's look this up. What happens if we open it just regular paint? Let's see what PNG says about color space. Oh, there's a chunk that will tell us if it's sRGB or not. Perhaps there's some tool we can use to read some PNG metadata. Tweak PNG, this looks awesome. Let's try this. I'll just drag it in here to access it. Cool, and then we can just drop an image in there. Cool, and what we were looking for was simply sRGB. That's not in here. It isn't here, so it is marked as sRGB. Running intense perceptual. Unsafe to copy. Perceptual. So the standard sRGB color space is used. So now I find it weird that if we put our swap chain to expect sRGB values, we get a correct output. Right. So if we mark this as sRGB, it will read sRGB and write it as linear. Well, it will read sRGB and then convert it to linear for us. So if we make our swap chain sRGB, it expects sRGB values, I think, to be written. Or just expect linear values that will write as sRGB. This looks really broken with black grass. We can actually load our gradient in and see what that does. Because if that's linear, then it's all good. But if it's not, then something is going wrong. Now it's really annoying that my clear color is black. So let's change that to this, some bluish color. So you just can see like most of our texture is black and then it suddenly transitions into white. Now we actually get that linear transition. So I would expect this to be correct. Let's see what happens when we load. I'll actually compare that to the gradient image we have here. Does that look the same? I don't know. It does to me. Let's load the other texture again. Is that the correct color? See, it's way darker. And we're not doing any lighting. Let's double check that. Yeah, let's just output the value that it reads. Just the albedo. Like, is it the background or something like that that makes it look like a different color? No, I think it really is a different color. And if we were to read the texture as if it's linear data, like this looks really washed out. But it looks a lot more like this. But I know you have to load the texture and then convert that into linear space. Oh, it doesn't like that type mismatch. Also, yeah, it doesn't like me mismatching this type, so it's so strange. Is STB correcting for sRGB for us? That could be the case, which I would really like it not to. Let's Google that. Because it's throwing away tons of precision if it does that. Change the SBI RGB to SBA RGB alpha. That's not what I'm looking for. Information. For pretty much all the maps, just use linear RGB. But then why? That is really weird because it's like the exact opposite of what I would expect to be correct. Let's use this tweak PNG some more. Also for the gradient, because I generate the gradient in code, and this isn't sRGB encoded. So can I even edit this? Can I like just get rid of this? So we'll get rid of the sRGB, get rid of the sRGB. This thing doesn't seem to care. Will this care? Oh, I duplicated that line. Like these colors still don't quite match up. This is slightly darker. They should be the same. And I would really doubt that this library does anything with sRGB. Load and post-process. What does it do for post-processing? HDR, TGA. Do PNG. It doesn't really talk about sRGB anywhere here. So I doubt it does anything with sRGB. This is actually really annoying because I was expecting this to take like 5 minutes of just setting sRGB flags, and now I'm just super confused. Why is that the case? Mm. So it's encoded in this space. I already googled for sRGB support in Paint.net, right? Yeah, this is RGB for CYMK. Yeah, you can see here the colors are different. So what I'm suspecting is that even though it marks it as sRGB, Paint.net just stores everything linearly. And now I'm wondering about a skybox that I found because I expect that thing to be sRGB. Um, yeah, let's enable the shading again, just see what it looks like. Because I think what we're looking at may be correct. Oh, we need to apply the shading again. Again, accidentally duplicating. This looks a lot better. It looks a lot closer to our funky texture. Like, dark colors also aren't as dark anymore. So, I think what we're doing is correct. And that Paint.net just doesn't encode stuff in sRGB. So we need Photoshop, but Photoshop is expensive. Yeah. Let's mark sRGB as done, but let's say look more into storing assets as sRGB. So let's talk a bit about map mapping and what it is for. So we have our test texture here, which is, let's see, that's the wrong tool. Let's see, it is a 1K by 1K texture. But if we show it on screen and we like move really far away, it will take up a lot less than 1K by 1K, which is a waste. because we're sampling from this really high resolution texture, but not showing the high resolution. It can actually see some artifacts on the texture that start to show as we're minifying it. That's also partially because we're doing linear minification, but perhaps we can see it a bit better on the bunny. So let's make it stop rotate so I can show you this. Somewhere I do this. Yeah, like if you look really closely on the texture, it starts to like sort of you get these weird effects that just don't look really great. So what we need to do is generate so-called mip maps. And mip maps are basically just smaller versions of the same texture. I think there's a great Wikipedia article out there which has nice images for demonstrating this. Yeah, so you can see here, without the mip mapping, you get these really strange patterns in there, but with mip mapping, those patterns are gone. It does become a bit blurry, which we'll fix later with anisotropic filtering. But even though it's blurry, it looks way better than having no mip mapping at all. So how do we use this mip mapping? Let's say we have this one texture. We simply downscale it to a quarter of its size, and then we do it again and again and again and again and again and again. And the hardware can select which mip map to use based on the difference in texture coordinates between two pixels. So we don't even have to do anything for it. The hardware can do it for us. And what's even greater, even more awesome about mip mapping in DirectX 11 is that it's built into the graphics API. So where we load the text texture, there were these miscellaneous flags, and there's a thing we can pass here, which is generate MIPS. And we'll have to look up some information about this flag to see how we exactly need to use it. Because no, there are some caveats about it. So it allows us to call the generate MIPS function. And it needs to be render target and a shader resource. So let's also make it bindable as a render target. And it supports these formats. We're using this one because apparently Paint.net doesn't like sRGB. And later more formats were supported. And I think for the mipmap count, we either have to pass 1 or 0. I think we still pass 1, but for this, we pass 0 to just use all the mipmaps. Generate MIPS. Oh, it actually wants us to use the shader resource here to do that? Now we can also do the mipmap generation by hand. Well, by hand, on the CPU. But it's a lot simpler to just let the API do it for us. So it failed. Let's see why it failed. Most detailed MIP value is 0. Between 1, 0, MIP levels minus 1 of the texture is 0. MIP levels must be between 1 and 1. So I think this needs to be 1. Awesome. Now what we'll see is that the filtering still isn't that great because they're not really doing filtering, but it is selecting the different bitmaps. So what we can do now is, remember when we did the point filter sampler state? Point filter, right here, point filter sampler state. We set it to use point filtering. We can now do a trilinear filtering sampler state, which will blend pixels together to give us a lot nicer effect. So let's call this trilin. And let's set this to linear. Now we need to create this variable. Trilinear filtering sampler state. And then we can bind that in our graphics, in our rendering code. Cool. And as you can see now, these edges that were like really hard now have this gradient going on. And from distance, when textures get smaller, it looks far better. And you also don't have that weird artifact as much anymore. There's still some aliasing going on, but that's just because the screen resolution is limited. And we can do multi-sampling, anti-aliasing, or different types of anti-aliasing. But we're not doing that right now. So if we really zoom in, we can see that linear filtering again. So that's like a little trick we can use to really improve the image quality. So that's texture filtering. Let's also actually talk about anisotropic filtering, which we can also use, which gives us a better quality. Oh no. So we can do another filter. And for the filter, we just pass anisotropic. And then we need some sort of max anisotropy value, and I think 16 is a good one. That needs to be unit. That's basically how many samples it will take. Anisotropic filtering is actually kind of complicated. I don't exactly know how it works myself. But as far as I understood, oh, that's not anisotropic filtering. Why is this image about anisotropic filtering and then this article is not? Anisotropic filtering, there we go. So as you can see, it remains sharp while trilinear gets blurry in the distance. But I don't think I really explain how it works. Like here, it's rip mapping versus mip mapping, where you create these maps of different width and height, which mitigates some of the problems. Yeah, I'm not really sure about how anisotropic filtering works. But as you can, like as it says here, like this has been around since 1990, so we can use this. The only thing we need to think about is that it's more expensive than trilinear filtering. So we need to decide which textures we want to trilinear filter and which textures we want to anisotropically filter. And we can actually we can bind anisotropic filtering. And I doubt I can really show it with this texture, but let's just say the texture quality will be better once we get better textures in here. So that's another thing done. Let's see, next up, Skybox. Alright, I found this really cool website of this person who makes skyboxes that you can freely download and freely use. And I thought this one was pretty cool. So let's download this one and let's use this. And now I'm wondering about the sRGB stuff, whether it's going to matter now or not. Cool. So it basically the cube map is 6 different textures, which you can place on a cube as the name implies. They've been named nicely, like negative x, negative y, negative z, positive x, positive y, positive z. So we can just load these in and get it working. So let's add another test loading function. And now we want to output, should we output 1 buffer or 6 buffers? Let's say we output just the 6 buffers as 6 different pointers. And we'll make it assume that all the widths and heights are the same, which is normal for a cube. So we want to load these 6 textures. Let's create these 6 buffers, and let's create an array of file names. Let's do negative x, negative y, negative z, positive x, positive y, positive z, and let's add commas after these. And we only need the width and the height once, and we'll just assert that they're the same for the other ones. Well, I don't even feel like asserting them. Feeling a bit lazy today. Let's just stick this in the loop. Let's just assert that we got a valid pointer back. Cool. Yeah, we can actually output all this data also here, so we can say out buffers like this. Actually, out buffers I is. And then we actually don't need these stack variables, but yeah, we don't need them. Let's just get rid of them. And then we output the width and the height. Cool. So let's call this function in our game. And this is like sort of the same pattern again. Skybox, stick buffers, or textures. Cool, and let's then upload it to our graphics system. Cool. Let's copy this, stick it in here. All right. I actually need to think a bit now. I'm already like thinking a few steps in advance right here. How we should render this. Whether we should just draw the inside of a cube, or whether we should do it using a full screen texture. I think I would prefer a full screen texture, but I'm not exactly sure how to do that anymore. Like I roughly know how you do it. I just can't really remember the details. Um, Now here's the weird part. We need to create a texture 2D to create a cube map, since it's actually 6 2D textures. Let's grab parameters for this. Width is going to be the width. Height is going to be the height. Erase the mid-levels is 1. And now I think the array size needs to be 6, or a multiple of 6 for a cube map, and whether it's an array of cube maps or just a single cube map. format GXGI format RAG8B8A8 unorm. I'll change the sRGB if we need to. Sample desk count 1, quality 0. Usage. We're going to bind it as a shader resource, select 0, and miscellaneous flags also 0. We'll pass the description, then we need to have the sub-resource data. And now I'm wondering about how we need to do that. Pass that exactly. We'll figure it out as we go along. Alright, that creates some texture. Then we need the shader resource view. Shader resource view desk. Description dots. Let's look at all the things. Format. Copy the format. View dimension. Now this time it's not going to be a I actually changed SRV desk. This time it's not going to be the standard view dimension of texture 2D because we're doing cube map. So view dimension texture 2D texture cube. Map levels 1. Most detailed map 0. And that's probably in different order. Yeah. Let's initialize in the struct order. And then we need to actually create that thing. Wow, I'm making so many mistakes. I'm actually more tired than I thought I was. Right, crash if it fails. Let's create the variables that we used. That's the insert button. But I believe it's still texture 2D. Yeah, it is. And they have the Skybox SRV, which we use to bind to the shader. And now these should shut up as well. Awesome. Now for that initial data. It might be the case that we need to stitch this data together, and D3D11 expects it in a certain order. So let's actually look up how texture cube works. Direction textures in D3D11. As a texture cube. 0 is plus x, then negative x, plus y negative y, plus z negative z. Also D3D11 does not support partial cube maps. Okay. So we should actually load the data a bit differently. This needs to go into one buffer. So we should actually load the buffers in here. Oh, should we load? We definitely need to change the order of things. Since one's negative x, positive x, so forth, so forth. Now this all needs to go in one buffer, and I don't think it really matters if we do that here or here. So let's just do that here. Stitched buffer. Width times height times 6. 6 times size of u and 32. And then we need to copy all those textures into that bottom buffer. So we want stitch buffer. Let's actually calculate which slice we're on right here. And this is actually slice destination plus a times width times height. And also the slice source, which is going to be skybox buffers A. And then it's simple slice we're just copying over the data with a pitch value. Oh, I called this SRV instead of source. So we copy the texture data into a single buffer because D3D11 expects it to be in this format. I will do that as the first thing. Then here we say data system memory is the stitch buffer. Stitched, how do you spell stitched? Stitched with a T. Stitched buffer, that's wrong. Stitched buffer. Now we need the pitch, and this is how big, how many bytes it needs to move forward to go down rows, which is the width times the size of a UN32. And now we for the first time actually need the slice pitch, which is the height times the width times the size of U132, which is how many bytes it needs to move forward to go to the next phase in our cube map. So I think this is correct. Let's see if this crashes when we run it, or if it just works perfectly. We crashed. Let's see why. Let's see if our buffer is fine. Our buffer seems wrong. Or perhaps it's just the color. Oh, the pointer actually seems fine. Data. This data seems fine. This description perhaps is not right. It just says there's an access violation reading a really high memory address. Oh, I think in the miscellaneous flags we can pass that it's a cube map. I have to look this up. Luckily, we have our good friend, the internet. And we can look at the miscellaneous flags. And I think if we look for cube, there we go. Texture cube. Should be graded from a texture to the array. So is there also texture to the array function? Texture cube. No, I think we should just. Whoa. I think it should be fine. Still crashes without telling us anything, which is always great. The debug device is enabled, but it's not telling us anything. Is there any other miscellaneous flags I need to pass? Don't think so. Does the array size need to be one that is trying to read, that's already expecting to be... Oh, right, because you can also make a texture cube array. Yeah, array values 1 is invalid. I'm creating a resource with texture cube array size must be must be greater than or equal to 6. So 6 is correct. Now I'm wondering, what if we don't pass any sub-resource data? What will happen then? Then it doesn't crash, so it's clearly breaking when we upload the data. And what I think might be going on, yeah, it expects an array of sub-resource data, so we actually didn't need the stitched buffer. Ah, that's what's going on. So let's do that then. So it doesn't really use the slice data, but doesn't really matter to us. So pass skybox buffers, then we can get rid of this. And now it seems to be loading. Oh, well, we didn't pass it, so we don't know if it's loading fine. Let's see if it loads fine right now. Yeah, now it's loading fine. So now we can go actually use our skybox. Just go draw it. So we'll need a new shader for this. Let's actually mark this off as on our checklist. And now we need to think a bit about how to do this. So let's create some shaders first. And then there's this really annoying bug in Visual Studio where we have to mark it as a vertex shader. Because for some reason I can't create vertex shaders. And I have to copy paste this. Then I didn't set all configurations, so I need to apply to all the configurations. Right, let's add a new item. Box.ps.hls. So we have our vertex shader and our pixel shader. Cool. Then we clear this and we clear this. So for the input of the vertex shader, I was thinking of just using the vertex ID. And then I need to think about the output. Because you can sample from a cube map using a direction. And we can basically calculate the direction without needing to draw any geometry other than something that is just full screen. Let's call it normal. This is actually the PS input. Let's just return white. And let's set the normal to some dummy value and see if these compile. They don't. Missing semantic. Ah, right. Right? That works. Well, like it compiles. So now we need to load in these textures, or these shaders rather. And let's actually get rid of this old code. That's better. In our shader loading routine, we can say load skybox with the shader. And this is not going to use any input elements, so we can just pass 0 and 0 for these. And then we can load the pixel shader. Vertex shader, pixel shader. And these should start matching up with those. Awesome. Now we need to think about our render function and see what state we exactly need. So we need the same render targets, same blend state. Now we need different depth stencil state, but we use the same viewport. Let's see, input layout is different, vertex shader is different. So we'll have to copy that. And let's put like a mark here and a mark here that we need to edit these. So we need different pixel shaders. Restorative state is the same. Primitive topology is the same. Vertex buffers are different, index buffers are different. So we actually don't have any vertex or index buffers. So what we'll do, once you've set all this state, is just say draw 3 vertices with base position 0. And it's not going to read anything from vertex buffer. So for the depth state, we want a no depth state. We don't want an input layout. We do want a vertex shader. Perhaps we can combine null for the input layout. Say no input layout. We'll load the skybox vertex shader, or set the skybox vertex shader and the skybox pixel shader. We can do anisotropic filtering for our cube map. And we want the skybox shader resource view. And then we need to do constant buffer data. We'll bind this to register 0. Sampler state, just sampler as 0. And what we can do is cubemap.sample with the sampler. And it would be really nice if it would actually show us intelligence. So let's Google it. Sampler state location. Yeah, for a texture cube it wants a 3D location. And I believe that 3D location is just the direction. Now the challenge is, how do we calculate that direction? This is where I need to think. Let's first see if we get anything on screen using this setup. We got nothing on screen. Do we get a bunch of warnings? Yeah, we do. Let's read this. Rasterization unit is enabled. Pixel shader is not null, or depth sentinel state is enabled, and restore stream is not. No restore stream, but position is not provided by the last shader before. Oh, because there's no SU position in here. Yeah, this is what happens when you're tired. So what I wanted to do was calculate the position based on the vertex ID. Else if 1, 2, and then let's see. So this is bottom left. Then we want to go up really high, so we'll make the Y3, and then we want to basically go. This is really hard to mirror. Want to go across and like go really far. So we want this to be 3. And then this -1. That will create like a big full screen triangle that covers the whole screen. And now we can also do UV coordinates. Just the text coords. And we might not need that, but we'll just add that in there. We need to negate this. Because of the different coordinate spaces. Or coordinate systems. So I actually have a position. And we're crashing. Because for some reason we're minimized, I think. Yeah, because it is working. We are getting the color white, and we can also output the UV coordinates. Talking input. Input. Then it crashes again because it's minimized for some reason. Now it's black. Not what I was expecting. Oh, this needs to be plus 0.5. Yeah, and then we get this simple UV coordinates thing rendered on screen. So we can basically do whatever we want now with like a full screen thing. And then for every pixel on the screen, we want to sample the cube map and then draw that pixel. And what we're doing now is draw the cube map as the first thing without any depth testing. But what we would like to do later on is draw the cube map last, so we don't draw a bunch of pixels that will get covered by something else anyway. So I am really tired, so let's just go finish up this cube map. So I'm wondering how we should calculate these directions, which all depends on the projection matrix that we're using. So, let's think about this. So the forward direction is it's doing that weird thing again where it's not drawing any lines. Which is really annoying. Oh, the color picker is set to white. Let's make this a lot less white. That's better. So we have a camera. Beautiful camera. Which is inside this cube. Our cube map. And then basically what we need is these directions coming out of the camera. One is really easy, which is the center, which is just a normal facing forward. But we have all these different directions going on, and we need to know exactly what these directions are. So what I think we need to do is take the edges of the screen, calculate the world space for those positions, the positions in the world for them, then take the camera world space position, then create a vector towards those, let interpolate the rest of all the vectors, and then use that to sample. I think that's how we need to go about it. So we need, as an output, next to position, we also need a, and this can just be a 3D position in world space. And we need some matrix for that. So we need a constant buffer. And this is going to be clip to world space matrix. And we're basically going to say output. Well, actually, we don't even care about the world space position. We just care about the normal. So we just calculate it locally. And then the normal is going to be the camera position, which will also pass. And that is going to be position in world space minus camera position to get a normal from the camera to the position in the world. And then in here, we can sample using the normal, and we'll normalize the normal here since we need to normalize it anyway because we interpolate it. And we can just simply return that sample. So let's think about this matrix, and let's bind all the textures. Let's not do the matrix, let's just do the texture first. Let's bind that first so we can see if we get anything on screen. That is not the file I wanted to open, this file. We actually bound the texture. So let's see if we get anything. Okay, we got something. Not what we really wanted. It's doing something I did not expect, which is that it's changing based on how we're looking. Oh, because we're using this camera position from a constant buffer that we haven't filled yet. So let's just create the constant buffer. So it's now calculating with a bunch of garbage data. There was something off about this name of this matrix. I'm using a different casing system. Let's see, camera position. Cool. And now the annoying thing is that I think I need to create a new constant buffer. So, constant buffers are really weird in DirectX 11 because they're nothing like what the GPU is actually doing. Yeah, I'll have to create just another one here. Let's just copy paste this code just to be fast. Skybox constant buffer, skybox constant buffer, skybox constant buffer. All the way up here. And that also means I actually want to move up this this matrix code to the top of the file, or top of the function, because we need it in our skybox calculation. I'm jumping all over the file. Where is my code? It's right here. Cookie42 says he is humbled to watch my program. Wow, I'm humbled by that statement. Let's see. We're doing a constant buffer, so let's bind this constant buffer. PS set constant buffers. We can just simply copy paste the code for updating the constant buffer because it's practically the same. We just need a new struct. Skybox, and we'll upload it into the Skybox constant buffer. By the way, people are watching. If you have any questions, like, feel free to ask them in the chat. Let's do an identity matrix because we want to just get something on screen first before we're doing any fancy calculations. Because I'm expecting this will give us sort of a static view that is all warped. Oh no, fatal error. Let's see what is up. Looks like it crashed here. Let's see why it crashed. Dimensions are invalid. Must be a multiple of 16. Right, that's a thing in D3D11. We need to add some padding here. Oh, I see there's a question. Cookie says, I'm a C# lab. I know just enough C++ and DX now what's going on. Curious why you call it a prototype. Is there something you're doing different than the traditional approach? I'm calling it a prototype because I'm just hacking this all together in basically one big file. And I just really wanted to create some water shading effect. The way I do programming, I like to just write things out in like a dirty way, like a really dirty way, and then fix it up later in a way that's actually useful. I don't really want to be bothered by writing a lot of code that doesn't really do anything. So let's add this padding in the shader as well, so these match up. So the way I think it's also how the hardware expects your data to be aligned is it expects data to be packed in groups of 4 floating point values. So it needs to be 16 byte aligned. So DirectX 11 gives us the restriction that it needs to be a multiple of 16. If you do DirectX 12, you'll actually find out it needs to be a multiple of 256 in total. So I'm not sure why they went with a different restriction in here. So that should fix our bug. Let's see. Okay, so now it's not reacting to the camera anymore, which is the expected output. But we get this really weird warped image. And I actually would really like to render the normals that we're passing to the pixel shader, just for debugging. Let's see. So let's actually do this. So this looks right because the normals on the right are getting positive x and normals top are getting positive y. Yeah, so the really weird graphical fact basically comes from the fact that um, it was a bit like our our texture, like our viewing plane was in the camera. So now we just need to add these matrices and that will fix everything. And I'm also thinking more about it. I don't think we need this camera position because the cube map moves with the camera. I think we just need to inverse the projection matrix and then apply the camera rotation. Skybox CB. So I already have this matrix to go from a from view space into clip space, and then the graphic card divides by W to go into um, what's its face in screen space. So I think we can just pass the inverse of this. And that should fix the weird warping, or at least give us some better normals since we're still drawing the normals. Yeah, now these colors are a little bit less intense. So I think that fixed the normals up a bit. Let's see what our image looks like. Our image is still really broken. I think we can actually do this without passing the projection matrix at all. I think we need a near plane distance. So we can do like the minimal number of calculations that we need. And then we need an aspect ratio. So what we really want is the parameters that we put into the projection matrix. And then we need some field of view. It's sort of like how you would generate the camera plane in a ray tracer. Trying to think back how you do that. So let's say we start with this position in clip space. We don't want to set the Z value to the near plane distance. Or the negative of the near plane distance. No, the near plane distance. And then we want to calculate the x and y value based on the FOV and the aspect ratio. So the FOV is basically the angle that we're trying to like how wide of a view we're trying to render. I think if we go into this code, let's just look up how you generate camera rays for ray tracer. Oh, generate camera ray in C++, or over here, generating camera rays. T near, T infinity, intersect, defining array, yeah, blah blah blah. Yeah, so like you got your camera position, then you have this plane, and then we want this direction for each pixel. It doesn't actually tell us how to do that. Creating camera rays. Yeah, so we have this plane. Times the tangent of the FOV divided by 2. Awesome. So we can just say 10 half FOV, which is actually this, which we're calculating in our perspective matrix, but we'll just calculate it again, just for ease of use. Not trying to do all the micro optimizations. Let's see, is actually cube map you're using, or is the lat long projection? No, it's actually cube map. But DirectX expects us to pass a normal, expects us to give a pass direction for the cube map. But you could do a sphere map with latitude, longitude. 10 half FOV will equal tangent of our FOV, which we'll put in variable. And our FOV is in radians, and I know an FOV of 1 is something that's roughly correct. Should just this be 10F for float? Yeah. Then we need the near plane distance, so we'll also make that a variable. And also need a far plane distance. Cool. We actually don't need the far plane distance, but I thought it was nice to also just stick that in a variable. And then we need aspect ratio, which is also here. Which is just width divided by height, really. And then we don't need the camera position, and we don't need any of these matrices, I believe. So let's copy this. Let's go, it's just padding. stick it in here. Then we don't need these. We don't need to inverse any matrices, which is always great. Let's get that article back. So X is, this I don't really care about because it's already an NDC. Image aspect ratio times that 10 value. So it's just going to be this. And then the same for Y. But for Y, we don't multiply by the aspect ratio, otherwise the aspect ratio doesn't do anything. And we can actually write this down like this. Cool, then we calculate the normal and then it should work. And declare identifier camera position. Right, because we don't have a camera position because the camera position is at 0. So it's just going to be that. That looks a bit like a cube map, except our y coordinates are flipped and we're not rotating. And our FOV seems very wrong. Let's fix the cube map first though. Yeah. So it looks like our source assets as the naming messed up a bit. Oh, and it's still not stitching correctly. Like you can see this really sharp edge here, so something is going wrong in there. So let's debug this some more. Really wondering why the FOV is so messed up. It's like the FOV is way higher than it should be. What if we just make it a lot smaller? Yes, progress. We can see the cube mapness. Yeah, if we make the FOV way smaller, it looks a lot more like it should be looking like. Perhaps our aspect ratio is our aspect ratio messing stuff up? Like that definitely just stretches it. So we're using the same FOV value. We're using the same tangent function. Also 10f. It's really weird if I just make this smaller, it just looks so much better. Yeah, let's add camera rotation so we can see a bit more what's going on. I think we don't want to negate these rotations. That's, I want to do this. For camera rotation. Then we need to actually multiply our position with that. See if the rotations are any good. Whoa. So, okay, the order of the rotations definitely isn't correct. Let's fix that before I get really motion sick. So these need to be swapped as well, because we're not doing the inverse of the rotation anymore. We're just doing the regular rotation now. So as you can see, the FOV is messed up, but the rotations work. And I'm really wondering why the FOV isn't correct. Like, this is obviously not right. Let's take another look at this this article. I wonder how this person calculates the Z value. Is that just a near plane value? So here they convert from degrees to radians, divide that by 2. This is just NDC space. We're already in that space, so we don't have to do that. It's a direction, so don't forget to normalize. We do normalize it. Why is this wrong? I'm already feeling that this is going to be one of those bugs that when we find it, it's going to be like, oh, how were we so stupid? Like, this is extreme FOV going on. It's cool because you can see like the FOV calculations in X and Y in these matrices. What happens if we change the near plane distance? Like, what if we add like 10 to this? Will that change that calculation? That definitely changes our calculation. So it might be that the distance of the plane isn't correct. Well, that actually, yeah, of course that makes a difference because we normalize it afterwards. So it also changes the X and Y values. So now I'm wondering if this near plane distance somehow doesn't match up with how you set this up in here. because changing the near plane distance in perspective matrix doesn't change anything. So perhaps we should just set the near plane distance to 1, and it will match up then. Yeah, that seems to match up. Alright, so the near plane works different for the projection matrix and for a projection matrix and a ray tracing thing. So we can just hard code this as 1, not pass pass the near plane distance, set this back to 0.1, get rid of this, make this a float 2, and then we should have a good cube map now. Yeah, now it seems to be working fine. Except that our top plane is flipped and our bottom plane is flipped. Now the question is it flipped along one axis or two axes? I think it's flipped on both axes. Yeah, so like this part matches up with this part. And this probably has to do with the fact that I think it's a combination of the left-handed system instead of the right-handed system, and that the v-axis on the textures is also flipped in DirectX. That doesn't explain why the other textures work. Let's reset the view and actually compare it to the input textures that we have. So this should be positive Z. That doesn't match with what we have. And negative Z is, yeah, negative Z is positive Z. Let's look at positive X. That also doesn't match. And this will be, yeah, so if we look up, this should be positive Y. Oh, that actually does match up. A negative Y? That is the bottom. So it's like our x-axis is flipped, but the y-axis is not. So let's do this. Really quick hack. Okay, that doesn't fix the stitching. Then I might also need to negate the Z. Which messes up the rotation. Still doesn't fix our artifact. So we can actually fix these up when we're fix some of these up when we're loading them. So these should be flipped and these should be flipped. Oh, that actually solves our problem. Yeah, I just had them ordered incorrectly. And positive Z actually, yeah, that matches up. Awesome. Cool, we got a cube map. Uh, can we really see it stitching up? I think this looks fine. Cool. So we got a height map. We got a skybox. We got sRGB correct shading. Well, sort of sRGB correct shading because I found out that Paint.net just stores everything linearly. Doesn't care about sRGB at all. Which is just, it's bad. I should look into buying Photoshop or something, like a real tool for textures. But I'm also not really an artist, so also sort of not really worth it. Cool. We got a skybox drawn using a full screen triangle. So what are the other things I want to do? So basically the plan is I want to create a water shader. And I want to do that by drawing a plane, which is going to be the water, then generate rays for every pixel on that plane, and then do ray tracing to figure out what it reflects and what it refracts. And last time I went over like the sort of the things that we uh, need to figure out for that. But we should really start with the basics. So let's create a water plane, and then let's have like the vertices move up and down as sort of waves. Actually, that makes me think, as I was thinking about vertices and updating those, we did do something for our height map, because the shading on our height map is completely wrong. As you can see, it's like it's not shaded at all. Because we never set the right normal data for it. We need to calculate normals. Totally forgot about that. Now I'm thinking about how we would calculate those normals. So let's add another thing in goals that we should do first. Fix the skybox normals. Skybox normals, height map normals. Our height map isn't. Yeah, it is cross product time for the normals. So if we go back to our, which is someone here, our really cool height map image. This file's getting really long. So this is like our top-down view of the vertices in our height map. We want to calculate the normal for each vertex. And that normal depends on what vertices are around it. We basically want to calculate the slope between vertices. And using that slope create a normal. Let's do some drawing so I can sort of visualize this also for myself. Well, good job, Paint.net. let's see. Let's draw this from the side first. So in the most simple case, we just have a straight line and then the normal points up, which is what we've been assuming so far, which is this. Now, if we were to change that second coordinate, our normal would be facing this way. But there is one problem, and that is that we don't store the normal on the face, we store the normal on the vertex. So what you actually do instead of this is you calculate the normal here and calculate the normal here. So far so good. Now this gets a little more tricky. Something under my nails. Gets a little more tricky when we have more than two vertices. So we can have a slope that is like this. So for the edges we can do the same thing again, which is use the vertex next to it to calculate the normal. And we can do the same here. But what do we do for this? There's two things we can do. We can either split this vertex into two vertices, give one this normal. Oh, the arrow is going to be way too big. Give one a normal that looks like this, and give the other vertex a normal like this. And this will give us hard edges. Or what we can do is calculate both those normals, and then actually add them together, normalize them, and then we get that normal. Is your height map mesh using shared vertices? Yes, it is using shared vertices. And the shared vertices are actually fine if you want smooth normal map. I think if we would really like some hard edges in there, we can just increase the resolution some more. So I'm going for this option. Now let's see how we do that in code. So here was our original vertex. Yeah, we had this function for just generating a flat plane. And then here we use that flat plane and then adjust all the y coordinates to apply the height map to it. And then what we need to do now is calculate normals on this. So there are some literal edge cases in the thing that we need to write. So with this grid that we have, with a vertex like this, we need to access this vertex, access this vertex, access this vertex, access this vertex. And perhaps we also need to access these corner ones. But for this thing in the corner, we only access this and only access this. So I think we should write the loop for the inner stuff first. I'm just asking questions to give you if I have no advice. That's completely fine. Yeah, it's fine to just ask questions if you want to know more. Yeah, I think we should write it for the general case first and then apply the edge cases. But I'm not sure if we should factor in the diagonal vertices that might affect the normal. Does that even make sense to do? I think it does actually. Well, perhaps it depends on how you do the triangle. Let's create this grid in paint.net. So we have this. I really am the best artist in the world. I'm so good at drawing straight lines. Okay, cool. So what I'm wondering is, we can either set up a triangles like this, or set them up like this. So you would have them all like that. And what I'm thinking about is that, let's say we're doing this vertex. I think that this diagonal would affect this, but this might not, because the edge sort of folds over, right? I really am not sure about this. Like, it makes sense to do the diagonals, I think. My understanding is you get the average of the cross product of all the connected triangles, but also not sure, yeah. So also about the cross products, what can we really cross product with? Can I wonder, can I do like a dashed line in paint.net? Oh, I can actually draw arrows. Hold on. Wow, if I knew this earlier. And I can do dashed lines. Oh wow, this is cool. Cool, I can draw dashed lines. So we obviously can take like this and grab this, use these two vectors to do a cross product. Then we could do a cross product between these, and then a cross product between these. But I wonder if we should also do this and cross product those. Or perhaps it doesn't even really matter, and we won't notice the difference anyway. That might actually also be the case. Let's just not deal with the diagonals, just to do something simple. See if we can get something that's close enough. And then if it doesn't look good, we'll do the diagonals. Yep, I'm going with that. So, to do the normals, we will loop through from 1 to height -1 to handle the main case, the general case. actually do this. And then we want to load the positions. I don't really care about making this efficient, so I'll just make this quick and dirty with lots of copying stuff on the stack. So this is going to be top left. We actually need to copy that in here. And then we have top right. Bottom left. And bottom right. And then we will create a pointer to vertex B, which is x0 times y0 times width plus x0, and that is like the current vertex. So we want to do some cross products. And we always want to create directions that go from our center vertex. So we always subtract that vertex. Let's do that. You found a nice little article of interest. Yeah, you can post it in chat. Let's open this up. Normals. Cool. Article how to calculate vertex normals for a mesh. This is very easy, right? Yes, but let's say when high quality normals at faster speeds than usual implementations are started. Okay, gonna go with divisions. Looping only once. But this is actually pretty interesting. Let's see. Ah, yeah, then it averages them. Yeah, and this also, like this also only smooths them if they're actually interpolated along the triangle. So along this edge, but not along that edge. Which I think makes more sense. Yeah. This seems like a lot simpler use case that we can just really quickly apply. So let's get rid of this. Yeah, that is awesome. Let's see how we can adapt this. So are the normals already 0 for us? We just need to load the faces, but we don't have face struct, we just have indices. So we'll just do this through, let's see, And then we increment multiples of 3, make this unsigned. Load entities. These are unsigned. Let's see. Okay. Let's actually also add this link for credits purposes. Right, and then we loop through all the vertices and normalize them. Yeah, let's see what that looks like. So that makes it really simple. Let's see, do we have shading? No shading. Something is going wrong. This looks fine to me though. Let's draw the normals. Yeah, they're all set to 1. So it seems to be not updating it at all. Oh, I know why. Because we initialized them all to up instead of to 0. So actually need to do that first loop. And since these are... I wonder if this should also be normalized or not. Okay, I think the normals are now inversed, so we can just switch these around. Yeah, that looks fine, except like there's some strange stuff going on here. Let's draw this. It's shading. Yeah, there are like definitely some artifacts in here. But that might just because we're changing so abruptly in height. But I think it looks like good enough for our little prototype thing. Cool. We got some shading. I'm just gonna mark that off. I don't really want to deal that much uh, with the height map. The height map is just there so we can have some sort of terrain in there. Cool. I'm going to refill my water bottle real quick, so I'll be back in like 1 minute. Alright, I'm back. Um, I was actually thinking about the crappy height map that we have. Um, so I was thinking how we could do gradients, and then I thought you can just do a brush and then give it like a real, put like make it like really soft, and then you get this nice gradient, which is exactly what I want. And let's not make it like the full depth, and then sort of like do this. And let's see what that looks like. That's actually a bit close to the edge. Let's just do that. Yeah. Let's store this. Yeah, replace it. And let's load that. Ah, yeah, this is what I was worried about. We got these like really hard edges. Well, this should be like smooth terrain going down. Well, relatively smoothly. Now I'm doubting how well I'm sharing the vertices actually. I might not be doing that a really good job of that. I might have split vertices. No, I don't. I definitely do share them. So this normal calculation is not quite behaving how we want it to. What happens if we normalize this? It's also a thing I'm wondering about. Yeah, height maps are usually stored in a higher position. I can also just scale it a bit less. Ooh, that actually looked a bit better normal-wise. Yeah, let's scale it a lot less. Let's only make this like 5. Wow, our peak is really is no longer a peak anymore. We're getting all these little blocky things. I actually want to set up a point filter for the texture filtering so I can sort of see what's going on. Like this is definitely some weird normals that are popping in there. You know, let's keep this normal code. Let's put that in a comment, and let's do it the way we would do it with the grid. And then we can compare them. Because I am thinking it's not really calculating the normals like it should be. Just normalize this. Interesting artifact from that methods. I wonder what would cause that. Yeah, I'm also not really sure what's causing it. So I think we should just investigate this some more. I'm gonna just sign this here. This might be flip normals. Graphics programming is all about flipping signs until something works. Ooh, that's actually crash. Because x is some ridiculously high value. Oh, because I'm comparing y to the width. These normals are definitely inversed. So let's flip the sign then. That's really broken still. Let's see what sort of data we're getting from this. So we're getting nan, which is not good. So top left, top right. And 9 and 8. Huh, not a number. Why are we getting not a number? Like these are definitely flipped because this is pointing down while almost all of them should be pointing up. It might be that this is a zero length vector. Let's remove this normalization just for debugging. Yeah, it's a zero length vector, which is weird because these vectors are definitely different, but it looks like there's so little difference that it comes out with a zero. Oh, so one of the vectors is zero length. So why is the top left the same as our position? See, it's -1 and then 0.0392. Oh, because this should be 1, this should be 1, and these should be 2. Because we have like 1 is the center, 0 is top and right, and or top and left, and 1 is left and bottom. Ooh. And then we don't need that negation sign. What happens if we also normalize these? So this does seem to get rid of some of the random like little splodges of shading that show up. Still some of that artifacting going on. I'm thinking we should also do the diagonals. Yeah, we can do like a before after thing. So that was after. Let's also look at before, just to make sure that it's actually different and we're not remembering it differently. Yeah, see? So here you have all the random splodges of normals. But with this we do not. Now we're actually not doing any normals. Haha. Yeah, no normals. Now we do normals. And Visual Studio is confused. Why are the random things back? Huh? That is really weird. Like we just got rid of these, right? Let's do a compile, like a full recompilation. No, because like, huh? Why are we getting these random splitches again? Same with this. Yeah, but this is like more of them. Let's actually do like a screenshot. Print screen. Let's stick that in here. This is roughly the same view. It's actually about the same. Well, this area seems a little different. Like this has a lot more brighter spots than this. But if we look at the random artifacts, they seem to be about the same. So now I'm wondering, can we actually do a 16-bit per pixel image in paint.net? I don't think we can. So I'm also really wondering about how much a difference higher precision will make. Yeah, like I also thought it looked better, but then we switched back and forth and now it suddenly looks bad again. Like, that is so weird. Oh, but what I just realized that we're also doing is we're actually only doing diagonals, not the straight ones. So what happens if we do the straight ones? That's actually pretty funny that we were going to do just top, left, and bottom, and we top, right, bottom, left. I mean, actually end up doing the diagonals. So top is y0, x1. Right is y1, x2. This is y2, x1, and this will be x0, y1. So this top, right, bot, left. And this is right, bottom, left, top. Let's see what this looks like. It did look better, but what did we change? Why did it look better? What? I'm just really confused. Also, I should do this using some accumulator system. So I don't have to make this ridiculously long add thing. Now my Visual Studio is hanging. Oh, it's working again. Plus equals plus equals. Just normalize n. Is it because we didn't normalize each thing before? Like we did this? Does that make a difference? Oh yeah, send a screenshot. Yeah, it didn't have the it didn't have the artifacts. Yeah, I think it's because we didn't normalize. We only normalized at the end. But I do think we should normalize these values. Calculating normals like from geometry is always a bit weird. That is so strange that the normalization makes that big of a difference. But it's also interesting how we like get sort of the same effect when normalizing as we did with the other algorithm. Let's take a look at this. I'm also wondering, floating point error of some sort. No, I don't think it's a floating point error, because it's more about how the cross product works. Um, so the length of the output of a cross product is the sine of the angle. So if they're not like 90 degrees next to each other, then the angle, like the length of the normal changes, and then when you start accumulating them, you get a different result. So normals, like if like the 90-degree angles, they count more towards the normals than the shallower angles. So that's why I think we should normalize them before adding them. The load times are getting really long. Yeah, now we got the random splodges again, like with really weird artifacts in here. Let's actually Google on how people do this usually. There might actually be a thing about this. Oh, I like flip code. I think there might also be a thing about this on 3dgap.com. By Gottfried Chen. Let's see. Seems to be slow, especially for a big height map, and if you do it often, like average rainfall water. Click the vertex normal only based on the height map, similar to converting a height map to a normal map, I guess. For every vertex normal, I take 4 samples, left, right, top, bottom, of the current height map pixel. This gives me the average slopes in the x and z direction. This results in two 2D vertex normals, one in x, one in z direction. Now I have to find 3D vector that projected the x is 0, z is 0 plane, so we give some slopes as the 2D normals, and normalize it. It's explained by looking at the code snippet below. The method should be considerably faster than doing all those cross products. The normals calculated this way are independent of the later triangulation of the height map, so they're not the same you'd get by averaging the surface normals. This is not noticeable in the results. Yeah, that's also a thing that we can do. Is that's actually the thing I originally talked about. Is actually, or that is what we're doing with the cross products, right? Calculating the normal of the surface and averaging that. But we're not even averaging it, we're normalizing it. So this might even give a different result as well. 1 to 5, yeah, just dividing by 8. But that might not give us something that's normalized, I think. Wow, this makes it really artifacty. I also don't think the problem really is with the fact that it's an 8-bit height map, 8-bit per pixel buffer, because like the changes in y coordinates are actually pretty small. It might just be that the actual resolution is too small. Yeah, so this sounds border cases. Let's look at 3D gap, because I think there's something about a height map in here. Let's see, graphics forwarding. I think it was somewhere in the OpenGL stuff. Normal mapping, environment mapping. It wasn't the DirectX stuff. DirectX 9, that stuff is old. CG. It's definitely not the QS stuff. Probably also not the Unity stuff. Math, maybe? That's mostly quaternions, I think. No, it doesn't have article on height mapping. Right, it doesn't really show the terracing on steeper slopes. Oh, that's about the mostly on shallow slopes. What is the terracing that you're talking about? I've never heard of that word before. Oh, that's like the yeah, this. Yeah, that's a pretty good description. So what's actually like a common height map resolution? I actually don't know. Oh, that's all about Unity again. That's the one thing I don't like about Unity 3D is if you want to look for anything, you always get some Unity article that is like totally not helpful. People tend to use raw formats or similar 32-bit formats. Yeah, the format it's really simple. You just store one height value per pixel. And that can be like an 8-bit, 16-bit, 32-bit value. It can be an integer, can be floating point value. But it makes sense to compress this stuff with at least like PNG, right? Because there's like lots of patterns to that you can compress. Someone on Reddit can get pixel height. Ooh, getters and setters for everything. Yeah, this is definitely wrong. This also doesn't make sense. Does it? Let's think about that. So obviously the x and y values cancel out. Do they? Like with up and down, the x value cancels out here. What is the y value going to be? The z value going to be? That's like going to point towards the down vector. No, I don't think this is right. The face normal should be normal of two triangles that form your quad. Yeah, that is really wrong. As a unit, Cookie says, oh, about unit showing every Google search as a Unity user, I'm sorry. Having Unity show up in Google in every search is like really nice if you're actually using Unity. So can't really blame people using Unity because Unity it's a pretty cool game engine. It does a lot of stuff, but it does all the stuff that I like to build myself. Mhm. The difference of the values pixel pixel using DDX and DDY. So here they calculate the normal during runtime. Is this what you want to do? I don't think you want to do that at all, because you're not taking the height of the other. Right, this is if you like apply a height map to like a normal map. Yeah, we're not doing that. Smooth models. This guy's in some magic values. His terrain is being weird. So I'm also wondering, because when we normalized each normal, it it changed the result. Well, I think it shouldn't be, because we got perfect 90-degree angles between everything. and we normalize the whole thing in the end. No, that would only be correct for averaging, I believe. Cookie says, I really like Unity as a programming for programming physics playground. There's a lot you can do with shaders and graphics programming too, but that can be really interesting. Like if you were to make your own rendering pipeline. Yeah, like if you're actually building a game, use the tools that are out there, but sometimes it's just fun to build the tools. Because I remember like lots of people were telling me like, why do you want to learn to build game engines? And they were like, you already have Unity and Unreal. You don't need Unity and Unreal. Yeah, but who builds Unity and Unreal? You still need you still need people who can do this sort of stuff. Yeah. Yeah. You probably also wanna check out Handmade Hero. I don't know if you've heard of him. He does a series where he builds a game from scratch, but like from absolute scratch. Like build his own square root function and everything. I really like that guy. Also, his programming style is really nice. Oh, it's always weird how you can get like these small things take so much time. Just figure out some stupid normal. Still wondering if we should normalize those or not for smooth normals. Like, does the length of the cross product, should that matter to us? Aren't there some like height map tools so we can actually get some better input data? Because it might just be bad data in means bad data out. Height map editor and paint program. Earth sculptor. This looks like freeware. Where do I download this? Ah, big download button. Must support vertex and pixel shaders. Well, luckily it does. Does Paint.net have a blur filter? I don't know. What would we do with that blur filter though? Effects, blurs. Gaussian blur. Like for smoothing out stuff? I'm actually quite interested what that would do. Let's check that out. Yeah, it might clean up the data a bit. Let's check it out. That gives like smooth transitions to everything. That's actually really great. But we still have the artifacts, and I think it might be the depth that's a problem. Because if you look at this, like if we have values to represent all the values in between this, that would be so much better, but we do not. What might even help, and this is a bit of a crazy plan, is to change the image size to like 256 by 256, like a best quality filter. And because we'll have a lower resolution, the interpolation between the values will clean the data up as well. I think that will work. So it might just also just be the precision that's really bad. Yeah, that is like 100 times better. It definitely is the precision and depth. That's the problem. So today I learned that the precision and depth is linked to the resolution of the height map that you want. Like the bigger the height map, the more resolution and depth you need. But let's actually check out this tool because now I'm pretty interested. Yep, install, next, install. Launch Earth Sculptor. Okay, the best tools always start with how to use them. This looks like great UI. Okay, so we have camera controls. E is forwards. A and Z are up and down. Caps lock is hiding the UI. Shift sets the tool radius and also the camera speed. Special function key. Pan zoom mouse. Okay, let's do the following. Let's screenshot this. Because I'm definitely not going to remember this. Let's see. File, new. Why would you... Huh? Oh, it's demo. So we have a limit on the size. It's weird that this is like a slightly different resolution. Let's explain. Let's see. How can I hide these tools? Wireframe. Grid. Color. Detail. Light map. Oh, hide UI. Oh, that isn't. Oh, of course, the tools are in these windows. This is a really complicated tool. Oh, press F1 to top of the screen. Cool. So I can't really. Oh. Yeah, this seems like a lot more detailed system. I'm wondering most about is if we save this, we save it as some map. Um, test of map. Is there any documentation how to read these? Can we like export this, save as, export, height map image. That's better. That's something we can actually use. Assets, test, PG. So now I'm wondering, how many bits per pixel is this? So we have this cool tool that we can drag it in. 8 bits per sample. I think it just does a lot more complex. A lot more complex generation of the terrain. Like I think it creates a way higher vertex count. I think we should definitely tessellate this at some point. I think tessellation will be perfect for this. Because then we can do resolution based on how far away from the camera we are. But I think like the smaller map is good enough. Oh, no, we wrote over our test texture. Oh, we can actually just do this. Yeah, this is height. Luckily, we still have our amazing texture that we can display. I was afraid we had lost our amazing art. Yeah, it's funny how something stupid like that, just having a smaller resolution, makes it look so much better. Yeah, this gives by far the best normals. And now we don't really have that terracing problem anymore. Like only if we really like have a hard edge in there. Cool. What this also means is that we now have a nice place where we can go put our water. Because I really want to like put a plane in here that's going to act as our water. And now we need to think about how I'm going to do that. I might just put like a plane at a certain height and just make it the same size as this plane, and then everything after a certain point is just water. Or just put the plane on top first, so everything is in the water. Yeah. Another cool thing that I'm thinking of is we can make mirror objects using the skybox. Hmm. Let's move the bunny or the bunny in that hole. Will you do tessellation on the water too? Yeah, once I get around to actually having water, we'll probably tessellate that as well. I'm also not sure how we'll do how we'll make like a wave effect or something. I'll just go for some flat water first, where we can do some nice refraction and reflection. Um, let's see, got a notification. Oh, whatever. Um, if you ever do emotes, you gotta have a Stanford buddy. Oh, bunny. Oh yes, I really should have a Stanford bunny. But I first need to get to like become a Twitch affiliate or something like that, I think it's called. And in order to do that, you need to like get some goals. So you need like 50 followers, stream a bunch of different days, have an average of 3 viewers, which I'm not quite yet at. 2.71 currently. Hmm. Yeah, we should definitely have a Stanford bunny emote. Yeah, because apparently there are not enough graphics nerds on Twitch that there is no Stanford bunny emote. What was I gonna do? Yeah, I was gonna move the bunny. I can actually remove this to do. I should also at some point just clean up the. Oh, it's a bunny. Should clean up the code a bit. Bunny position. Um, Now let's first move it 5 units up to see if it's working. Right, that works. Let's see how we actually, where we need to move it. So it needs to move to the left, so that's negative x. Do you use any 3D modeling tools? So far not. While I was in university, I had to do like an assignment of making a helicopter in Maya, and I basically found this really weird either World War One or World War Two helicopter that was basically it looked like an airplane, had the propellers on the sides, and I modeled that, and it was really ugly. Yeah, I'm not much of an artist. Like if you just look at the amazing texture that I drew. There we go. The bunny is almost at the position where I want him to be, or it to be. I don't know its gender. Maybe it's been a girl bunny all along. That's roughly in the center. I am strongly behind the idea that art is a learned skill for most people, but it can be done. Yeah, I definitely agree. That art just takes. Well, I think there's definitely talent involved, but also just a lot of practice, like a lot of practice. Really takes dedication. Yeah, definitely. As do a lot of things in life. Okay, cool. So our bunny is in the pool. I will make him rotate again to show off that it's real time. Cool. No, for this water effects. Let's look at the to-do list that I accidentally closed, looks like. So we fixed the hype abnormals. Need to generate a plane, then do some tests with arrays. Let's do a plane first. So we have this cool function called generate plane mesh, that outputs in plane VB and plane IB are all planes that we can really nicely reuse. But I'll rename some of the variables. Cool, everything still works. Almost 2,000 lines already. Renderers just grow so quickly in size. Okay, let's look at the shaders that we need to set. Water plane. When did you start on this? Well, that's actually a bit complicated. So I was doing like some little base framework stuff where I had like a a platform layer. That's what I was looking for. Then I messed a little bit around with Vulkan, a little bit around with D3D11, then decided to D3D11. And then I started streaming, where I actually started building stuff. So basically I went from a black screen to this in 2 streams of 3 hours, and now this stream, which is almost 4 hours. So that is 6 plus 4, 10 hours, roughly, to build this. Like the actual code that does stuff. I also had mGUI already working for this, because mGUI is just really nice to have in your project. Yeah, definitely experimented a bit before I moved on to making real stuff. And that was like I was first thinking of building something completely different, like a 2D game or something. And I never got around to making anything because I was just getting so distracted. And then I just thought, you know what? I'm just gonna build this one small thing and I'm gonna stream it live, so I really have a reason to stay focused. That really helps. So I didn't really start streaming to make it like educational or something. I just started streaming so I have a reason to stay focused. Why do I use DirectX 11 instead of Vulkan or other library? DirectX 11 is awesome if you just want to build something. Vulkan is really cool if you want to get into low-level GPU optimizations. DirectX 12 as well. I have built stuff in DirectX 12 before. But you constantly have to think about like synchronizing stuff, and you have to deal with all these resource states. It's a lot of work. You do get more performance. Well, at least on AMD you do, and NVIDIA, usually DirectX 11 is even faster. Um, but it doesn't really, right now DirectX 12 doesn't really solve the problems I'm trying to solve, which is just they get some cool stuff on the GPU running. You should always, when picking a tool, think about what is the thing I'm actually trying to do, and then pick whatever is best for that. Yeah, DirectX 11 is far more straightforward to build something in. And DirectX 11 like supports most of the other stuff that you find in all the other graphics APIs. There are a few exceptions. For example, I'm not sure if the ray tracing stuff is in DirectX 11. I don't think it is. And also the what's its face? The draw indirect. I also don't think that's available on DirectX 11. But draw indirect is again optimization, which I'm not really worried about. What I am worried about is why my plane is not square, even though I scale it to be square. Oh, index count isn't matching up, that's why. It's just drawing half a plane, or a quarter of it. Awesome, so we just move this a little bit lower. So put a -1 and scale it up a bit bigger. And then we have a nice plane for our water effect. Just trial and error, that's the way to go. Yeah. But I hope to, oh, it's gone. Oh, wrong direction. Oh, I moved it 10 units instead of 1. I plan on actually porting this to DirectX 12 and or Vulkan once I have everything running. There we go. We have a cool water plane, and it looks nice and round, even though it's not. And a rabbit is beneath. So now we can go create a shader for this. Water. Well, just water. And I can actually reuse most of this. Oh, I can also get rid of this old code. Getting rid of old code is like one of the best things in the world. To just look at something and be like, yeah, we don't need this anymore. Let's just delete it. I'm going to copy this path. Vertex shader, cool. And let's set a pixel shader as well. It's really annoying that you can't just set a default macro or something for the output file for the shaders. Yeah, we'll just make it the same shader and then we go from there. Nothing wrong with copy pasting a bunch of code, really. I'll just call this water input layout. In case you want to change the vertex layout. Water, water. Yeah, that looks good. Prototyping is always something that's so awesome because you just dump everything in one file and it's actually so surprising, such a surprisingly efficient way to work. Because you just write the code that does stuff and you don't think about any architecture or any of that stuff. Just quick and dirty, simple things to get something done. Water, water. We need a water constant buffer. I actually want to bind the skybox. So we'll be using that. Let's actually do the test sector still. Let's do this one step at a time. Really do the vertex buffers. Oh, did I paste this at the wrong part? Yeah, I pasted this in the wrong thing. Water pixel shader. I need a water constant buffer. I really don't like the way constant buffers are done in DirectX 11. It's like one of the best improvements in DirectX 12. It's easier to use, and it's closer to what the hardware does. So cool. Yeah, where do we create all the constant buffers? Right here. So much boilerplate. Going to need these two matrices, definitely. And this should give us the exact same output, but run with a different shader. And it gives us nothing, so we did something wrong. It's not giving us a warning. Did it bind the correct stuff? I set the input layout. I set the vertex shader, the constant buffer. I didn't upload data to the constant buffer. That's what I'm missing. Well, I uploaded data to the constant buffer, but it's the wrong constant buffer. So we need a water C buffer. Water C buffer data, because this will be different from our main rendering thing. And this is going to go in the water constant buffer. That broke everything. Okay, what is going on? So our rabbit is now on our height map. Our water plane is really big. Oh, because we set this needs to be right. I'm probably doing something incredibly stupid. Yeah, I'm changing the wrong constant buffer. Now let's change the right constant buffer. I just noticed you can type water with one hand. Oh. And most of buffer as well. I love words I can type with one hand. I don't know what it is about them. It's just really nice that you can just like, yeah, typing something, one hand. We should have some words you can type without hands. That would be really cool. Ah, now we're getting the result we want. It's the same thing we had before. So let's go change this shader. We don't need this texture anymore. But what I would really like is skybox in here, which is 0. So let's bind the skybox. And then we don't want to do any shading really. We don't care about the lights. Well, not yet. We do care about the normal. We don't care about Lambert. We don't care about an albedo value. Well, we can sort of create an albedo value later. We don't care about shading. Yeah, awesome. We just want this. So we have a normal, which is going to be green. But let's just double check that it is green. It is green. Cool. Then what I want to do is create a reflection ray. I need the view vector. So let's find this. Let's create. Do we create a new constant buffer for it, or do we keep the old one? Let's just have one constant buffer. We want the view vector in world space. We'll use this view vector. What we'll do is I think it's called reflect. So we need an indecent vector and a normal vector. And the indecent vector is going to be the view vector. And the normal vector is going to be our normal. And this will create a reflection ray. So, reflection direction. So let me draw this for you so I can show it. So if this is not what the water should be like. Let's have a, okay, if this is our water plane, we want to calculate some reflections on this. So we basically have a view vector coming in, and we have the normal of the surface, and we want this vector, because this is going to be the reflection vector. And you simply do this, if I remember correctly, is you add the normal to this vector twice, because this vector is the same as this vector, and if you add the normal and you add the normal again, if I would have drawn this a bit better, you add these vectors, you get that vector. So that's why we need the view vector. And then we also need 4 bytes of padding, because the GPUs want that. So let's copy that over here. And let's calculate the view vector and put it in that constant buffer. Oh, Cookie, by the way, if you have more questions, like, feel free to ask them. I really don't mind answering them. I was just trying to like focus on on one thing for a bit. C buffer.view vector data.view vector is, how do we calculate the view vector? We just take the view matrix and multiply that with a vector pointing forwards, and take XYZ of that. And this is probably the least efficient way to do it, but it works. At least we'll see now it works. We're still outputting the normal. Let's output the reflection. So it's always 0. That doesn't seem right. Or it might be upside down. Let's output the view vector. I messed up view vector. The view vector is always black. Let's disable backface culling for the water, just for debugging. Okay, default restore states. Okay, that is weird. So does this always end up as 0 on the CPU side as well? No, because it seems to be correct on the CPU side. I added it to water C buffer. Oh, yeah, we are setting that constant buffer. And we're not setting any other constant buffers. Oh, I need to bind the constant buffer to the pixel shader. That's it. Awesome. That is definitely... Is that a correct view vector? Because this should be black. Well, this should be green. Like, it seems fine for Z, but it seems inversed for Y. But the view matrix would convert world space into view space. No, this converts... Yeah, we want view space into world space. So there's two things we can do. We can either convert the normal into view space, or just take the inverse of this. I'll just take the inverse, because it's quicker to do. Yeah, now it's black, and if we go down, it becomes green. Perfect. And then it also turns red for positive X. Cool. Let's draw the reflection rate that we got. Seems fine. Can't really see what's going on. Sampler. Reflection. I'll just return this. So we sample using the reflection ray, and that should be good enough to give us a mirror effect, which is definitely not working. Okay. Perhaps I'm thinking wrong about this this view vector. I think I'm definitely thinking wrong about this view vector, because this view vector changes based on where in the image we are. Right, because this is going to be constant for that whole surface. So we can just totally steal the view vector from this. Can we? So I remember in older codes always passing a view vector as a simple normal. But that might not be correct. Yeah, and in ray tracing the ray is different for each pixel. So I think doing this is just wrong, and we should do something like this in our water shader. So this is actually not, oh, this is, haha. It's simply the direction from the camera to, oh, I remember, yeah. You don't pass the view vector, you pass the camera position, and then you output the view vector, and then right, so we get a normal from the camera. We get a vector from the camera to the actual position in the world, and then we can actually normalize that. So we don't even need this constant buffer in here then. Right. So we stop binding that here. This is going to be camera position. And that should fix it. If we don't field compile. Oh. Let's actually copy paste this just so it's exactly the same. I also have a bunch of warnings. I should go probably fix those. Well, we sort of have a reflection. Like you can see the building over there. But it seems to be really stretched out. See that? Like it's extremely stretched out. D3D11 reflect. Oh, it expects the view vector to be in the other direction. Again, negating. But now we're looking like this is the ground. That's also not correct. Let's draw the view vector again. So we want the view vector to be up because it needs to point toward the camera. Yeah, we're just reflecting the skybox right now. I want to do some geometry reflections later on. It sort of depends on how much we can ray trace. Because doing everything fully ray traced is just not gonna happen on my GPU. So let's actually flip this here. So it's from our input position to the camera. It's weird because it's moving in a different direction than my camera is moving. Am I even dealing? Oh! This is not the world space position. This is the world space position. So we need to pass the world matrix. Okay, now we're looking straight through it. So what happens if I inverse the view vector again? Which is strange because it seems like this wants it to be in the other direction. Yeah, that is a lot more like how we want it. That's actually perfect. You can see real direction, real reflection now. But as you can see, like if we look all the way like this, like we can see that treetop. Like we can even see that building in the reflection, but we can't on the main camera. So you can clearly see that we're not reflecting that little spike there. So let's also add refraction from just skybox. I know there is refract, yeah. And then some index scalar, perfect. Let's look up the refraction index. Oh, refraction index of water. 1.33. And this water is going to be 20 degrees Celsius. Now, by definition. Oh, 1.2, says Cookie. That was pretty close. Yeah, that seems to be refracting. Now we need to do some more calculations, and we need Schlick's approximation. Now, Christopher Schlick. I don't know where he's from. Let's look. Let's see where he's from. Christopher Schlick. Can we find information about him? He sounds a bit German. Schlick. He basically came up with this really cool approximation for the Fresnel factor. And we can use this Fresnel factor to figure out how much we should reflect and how much we should refract based on the incoming angle. So let's copy this formula over. So r of theta equals r0 plus 1 minus r0 times pow 1 minus cosine of theta power 5. And in that equation, r0 equals n1 minus n2 over n1 plus n2 squared. So then r0 is r0 times r0. Let's double check that's correct. R0 is n1 minus n2 divided over n1 plus n2. That's squared. R0 plus 1 minus R0 times 1 minus cosine of theta to the power 5. Okay, what are n1 and n2 in this case? Indices of refraction coefficient for light. Theta is the angle between the direction from which the incident light is coming and the normal of the interface between the two media. So in this case, it's talking about light, but I think In this case, we talk about the view vector. Yeah, n dot v. So this cosine theta is just the dot product of the normal and the view vector. And let's do that like that. That to the power of 5. N1, N2 are the indices of refraction of the media and the interface, and R0 is the reflection coefficient for light parallel to the normal. Theta is 0 for minimal reflection. In computer graphics, one of the interfaces is usually error, meaning N1 can be approximated as 1. Right, so that's basically always the case for us. So we'll just say float N1 is 1, float N2 is 133F. Then we can calculate this. And this is basically for now. So we have this, we have that, we have that. Yeah, we have all the values filled in. And then we return raffle. I think like that, or it's flipped. One of the other. One of the two. Convert const float 3. Oh yeah, this needs to be cast to float 4. So I'll add an empty alpha value. And that fills the load. And I already have a clue why it is, because it's a really, really hacky loading code. How big is our shader becoming? It's 18 kilobytes. Let's see, what is the limit for loading our shader? It's 32 kilobytes, so we should be able to load the shader. So let's see, why is it failing? There's two semicolons here. And which one is failing? Oh, and we should return these results. So I think it's definitely the second one that's failing. Oh, it's failing completely somewhere else. What? Yeah. Like it must be somewhere in the shaders. Okay, we don't even get to hit our shader code. Our program just decided it no longer wants to run. This doesn't even get hit? What? Okay, let's go to main. Win main. First line, what's up? Page size. Yeah. We allocate all the pages. For all the pools, so guard pages. Commit the guard page. Commit the memory. And the guard page after it. Yeah, set the Win32 memory, start the H instance, create the window, get the window size in GUI context, initialize graphics. It's using an old file? What? Okay. These compile times are getting long, 7 seconds. Is Visual Studio not just saying I don't care anymore? Oh, now we're in here. Let's see. Where does it break? This is all fine. This is all fine. Yeah, create the factory, make the window association, get the adapters. Well, just get a adapter. I don't know when it stops. I think it should. Oh, this just lists all the adapters, and then we grab the first adapter. Debug device, feature levels, create a device. That's fine. Create a mod sampling texture that we're not using because that's still from some old stuff I was doing. Let's see, the first thing we can return from is load shaders, which would make sense that it would break because we're editing shaders. Vertex shader, pixel shader. Result 0, and I think this will break. Oh, this one is still small. Yeah, we need to up the size on this to a 32K buffer. Because our shader became 18 kilobytes. It's funny how they're about the same size. There we go. So our Fresnel effect's obviously not working. Also, some stuff is black. Although, if we look at it like this, like there is some reflection mixed in with the refraction. I wonder if just passing the refraction index is enough to refract. Refraction index scalar. If the angle between the entering ray I and the surface normal n is too great for a given refraction index, the return value is 0. Nice and vague. Yeah, because I think we need to divide n2 by n1 for this. But that would make it the same, right? Because we're coming from air, which is 1. By Snell's law. That's a lot of math. Ah, this is the whole function. Yeah, so we don't care about this. Well, refract should do all of this stuff for us. Yeah, and it assumes it's going to or from air. It just doesn't look right to me for some reason. But that might be just because we're refracting the skybox and not like what's actually under there. Ooh, that looks really funky. That's just awesome. I was thinking, I saw this and was like, where did this night sky come from? But then this, whoa! The universe is exploding! The Big Bang is happening all over again. I wonder why the colors break though. Oh, because Fresnel factor gets messed up, obviously, with a negative normal. I also still wonder which one I should negate and which, like, and which one I should just multiply with. I think it's like the closer you get to like to be level with the surface, the more it should reflect. I think that makes sense. Is the effect reversed? Steeper angles should be more reflective. Yeah, so I think this is correct, where you can see like as you get closer, it gets more reflective. It's just the refraction doesn't look any good because it's the skybox, I think. I also just realized we had this point filter that we assigned real quick. Yeah, we should get rid of that. Yeah. Steeper, yeah, more shallow angle. Yeah, like the closer you get to the water, the more reflective it should get, and if you get inside, it should become an exploding universe. Apparently, that's what we've really discovered today. Oh, this looks pretty cool. Too bad we're not ray tracing the height map yet. This just looks so weird. I really want to ray trace that rabbit. But perhaps we should start with a triangle. You know? Uh, we can sort of figure out how this is going to work. So we'll need a ray structure, which is going to have an origin and a direction, and also a distance, but I don't like storing the distance in the ray. And then we're basically going to do calculate reflection ray, calculate refraction ray. And then what we'll do is ray trace reflection ray. If it hits, if it didn't hit, do screen space reflection. If it still didn't hit, we want to sample the skybox. And this will be like the last thing we implement. And then we want to do ray trace refraction. If it didn't hit, sample skybox, or perhaps not even. If it didn't hit, just make it black. So I don't think it even makes that much sense to sample the skybox for that. We can even do that now to really really show the reflection effect and how Fresnel is working in that. Oh, where did that 6 come from? Yeah, because you can see, like, if we're looking straight down, no reflection. If we're like moving at this angle, we get like lots of reflection. So this sort of already slightly looks like really, really deep water or something like that. Oh, what we also need is implement Beer's law. And Beer's law is awesome because in order to render a glass of beer, you need Beer's law. Beer's law is actually not that complicated. What it basically describes, yeah, right here, is as something is moving through something with color, how much of the color you should apply as it's going through that thing. So the longer it goes to something with color, the more it should reflect that. Yeah, between the absorbance of a solution and its concentration. Yeah, cheers. What is the Beer's law equation? E is the molar extinction coefficient, L is the path length, C is the concentration of the solution. But if we look for it in a ray tracing context, we'll probably get some cool stuff. Oh, this is Demo Fox. This guy is also really cool. He does lots of cool stuff. Fraction for now. Yeah, that looks sick. Beer's law looks awesome. Did it link the shader? Oh, I linked the shader toy. That's really cool. Shader toy is also just awesome. Yeah, that looks great. It's like it's just ray tracing one cube and one sphere and then just sampling the skybox if it doesn't hit anything, which is exactly what we're gonna do. And this looks like super realistic, except for the shadow. Because if you want a really good shadow for glass, you would need caustics, and caustics are complicated to render. It's really expensive to render. I don't even like you need some sort of potent mapping system to ray trace it, or you need to go straight to path tracing. Good stuff. Light physics is fascinating. All the hacks graphics programmers use. Yeah, I mean programming this sort of stuff is always about simulating it. It's never about doing the actual thing that happens in real life because that's always just so complicated. So yeah, cheers to crazy hacks that make it look like real life. Yeah, we can definitely use this article once we get some water going. And we can have some colored water. Although water doesn't really have that much color. Like I was once told the reason the sea is blue is because of the air, because it's reflecting. Let's actually Google that. Why is the sea blue? Yeah, they are. Yeah, it is about water absorption though. So I think we should add a little bit of beer salt, like just a slight amount. It's also with yeah. Also probably because of the sunlight. So I should just add a triangle, right? I should add some coordinates for this though. Figure out the coordinates for it, and then just hardcode a triangle. Just be like V0 is some flow 3, V0, V1, V2. And then we can totally do a ray trie intersection. We can do some type, pass the ray, pass the triangle. And then we want to in out t value. And then return bool whether it hits or not. Yeah, I'm gonna take a short bathroom water refill break, and then we can do some ray tracing, ray triangle intersection stuff. Also, will you use sky simulation also? That is actually really interesting. Once we have the water working, we could totally look into that. I have no idea how you would simulate a sky. Like, I literally do not know. That would be really cool to do. Sun scattering, yeah. What is there some stuff about sky simulation? The ray tracing. That's some paper behind a paywall. Sometimes helps just add the graphics API or just OpenGL. Realistic OpenGL sky simulator. Like, this looks awesome. I don't know how realistic this is though. Because this is like a really dark sky, but that might even be sort of correct. And then we can totally draw this into a cube map. And then just sample from that cube map when we do the water. Is it just one shader? What? It's just that little code? No way. It can't be that simple. Hosek Wilkie. Two spots of light 180 degrees apart. Is this someone who created like an algorithm for this? Oh no, that's just a project name. Hosek Wilkie Sky Simulator. And there's some magic formula in here with an array of params. I have no clue what these params are, but it's probably somewhere in the Rust code. Hosek.rs probably has it. Not really familiar with Rust. Ah, looks like a lot of the calculation might be CPU side. Oh, that's just a really big buffer. I wonder what these values are for. Impulse shader. Filing source code errors, error messages. Linking the shaders. It's just a main. Vertex data for cube. Create a window. Oh, things are constant by default in Rust. That's interesting. Yeah, load shaders, against shader program, create a bunch of buffers. Main event loop. Unsafe. Params uniform. Mem transmute param 0. Recalc sun. Ah, this is where a bunch of magic happens. But we can totally, I think, use this. Let's look at the license for this. There is no license, or then I'm not sure if we can touch this. So I really don't wanna I really don't want to like use some assets that I'm not allowed to use, or yeah, copy some code that I'm not allowed to copy. The Skydiving Branch project. Is this? Oh, these are Hosek and Wilkie. Oh, that is awesome. I am totally bookmarking this later. All right, but I'm gonna take a break for now. I really need to go to the bathroom. So I'll be back in like 5 minutes. All right, I'm back. Yeah, let's figure out a triangle and let's do a ray triangle intersection so we can refract the triangle. So we need to figure out a good position for that thing, and we can do that based on our water position, which is somewhere right here. So let's just try pause. Oh, it's at -2 and then 5. That should be a triangle. And then we can do ray triangle intersection. So let's look up how to do that, because I always forget in HLSL. Ooh. Also, I got a beer because we were talking about beer slaw, and you know, beer slaw, need to get a beer. It's a shader code for the shader codes. Ray triangle test. Is this how you want to do that? Intersection. I don't like how this code is structured. Let's just grab the C++ one and then convert that to shader code. Muller Trimble, yeah, that could be the one. This is really common. There's some epsilon values. U and V. Oh, if you want to output the UV coordinate for the triangle, yeah. Let's just grab that. Let's actually cross product. Let's see if this matches. Oh. Oh. Ah. If it's determinant. What is the determinant? This is not the whole code. Oh, first we have to calculate a determinant. Oh no. It's even longer. Cross the direction with V0, V2. So let's call this E0 and E1. Yep. Some epsilon, let's define that. We don't do culling. Or we can do culling. TVAC and PVAC. This is E0. E1. That should be good. Let's fix both the variable names. That's actually not created triangle structures. I think that makes more sense. Let's add the source. Yeah, we definitely want the position and world space in our pixel shader. This is becoming a lot of values to interpolate those, so we might get rid of the view vector in the vertex shader and calculate that in the pixel shader. Yeah, the origin is going to be, this is always a bit funky, the origin is going to be position in world space plus the direction times some really small value. Well, actually, we don't have to care about that because we cannot intersect with the water itself. Although we could if we start animating the water. But I don't think we're going to handle light leaving the water, entering the water again, leaving the water, entering the water. That's just really expensive to compute. It's about getting something that's close enough. If it, I want to say Let's make the triangle red. Let's make it white. White is a nice color. Let's do a raffle color. Let's take a look at that. Unrecognized something something. Oh, it needs to be floating. Undeclared identifier direction, because that's radar direction. I'm also missing the origin somewhere, I think. Yeah, radar origin. Undeclared identifier. D1. What is D1? What is D1 thing? Is there even a D1? Oh, that should be E1, right? And this should be E0. And this should be radar direction. Undeclared. Yeah, E1 again. I was typing D for all the E's. So do we see a triangle anywhere? Okay, let's not refract the ray. Let's just say the refraction ray is the view vector. Well, negative, the view vector. Yeah, because we're not hitting the ray at all. Hitting the triangle. It's annoying because we can't see the triangle in rasterization. We can only... Oh, there we have it. No, that's... Is it partially our triangle or also our reflection? Let's set reflection to 0, so we can actually see what's going on. Yeah, there is some sort of triangle, but it's really broken. So this code doesn't work. Let's debug it. E0 dotted with pvac. If term is less than epsilon, return false. Oh. Let's not do the culling. It's just behaving really strangely. Oh. Is the... Yeah, the ray origin is correct. Oh, and this should all be try position plus, and then I'll probably scale this to small triangle. It's just acting really weird with the camera. Are you drawing this triangle in the scene too? No, I'm not drawing it in the scene. I hard coded it into the shader, and I'm just ray tracing it. Like I can sort of see that there's something here because it is outputting white. It looks like the intersection code is just really broken right now. And somewhere in here there is just a bug. It's causing it to behave weirdly. U is less than 0, U is greater than 1, return false. QVAC is cross of TVAC and E0. Oh, oh yeah, you didn't see in the scene, right? Never mind. This is the same, right? The winding order should not matter. Because they're not doing the culling. Yeah, the U and V give you barocentric coordinates. What's my thing? It's doing nightlight again. Nightlight is not nice if you're doing graphics programming and actually care about the colors. Oh, I didn't put it on the Z plane. I put it on the Y plane. Well, on the Y plane, no, on the X, the X, the XY plane. Yeah, on the XZ plane. I want it to be a flat triangle in the water. But still, it's like you can see it behaving really weird. Like it's totally not how we expect triangle to behave as we're moving the camera. Let's also just disable for now. Let's just return the refraction color. This can just be an assignment. Is view vector the vectors of the pixel? The view vector is the vector from the world space position to the camera. So it is of that specific pixel in world space to the camera, which is why I take the negative view vector to be from the camera to the world space position of the pixel. So it's just going in a straight line. Oh, I need to make this a 44. I'm also wondering what I'm getting for the t value. It looks to just be 0, which is also definitely wrong. Oh, I'm dividing it by 0. That is 100% definitely wrong. Never divide by 0. But it's not changing color even though I'm getting like coming close to it. Oh, this is also interesting. Let's think about this. What is happening here? So the view vector is correct and the world's position would be correct. So rendering from this angle would also be correct. However, the triangle is below the water, if I am correct. Yeah, because the water position is from -10. So this should be like straight under the water. See, -1, -1, 1, -1. Yeah, it's like a triangle like that. That should just work. What happens if I enable the culling? Let's see which side is the back face. Yeah, the culling also doesn't deal with the back face. That's also really wrong. So it's already going wrong right here. We calculate the edges. We cross the direction with that edge. So that gives us an. What does that do? Let's draw something again. So we have a triangle. And there's a ray coming in. So we take some vertex and we cross that with the direction. So we like crossing this, which gives us a vector that is like that way. And we dot that vector with, oh, with the edge actually. Hold on, that's, my drawing isn't correct. With the edge, so we cross it with this. So if we were looking straight at the triangle, huh. Let's just see if there's another triangle intersection thing is that we can steal and see if there's a difference between them. So this is the same. We didn't normalize the ray direction. No, we did. We did normalize the ray direction because it's normalized right here. Hmm. Determinant is the dot product of E1 and P-vec, which in our case is E0. If you want to do culling, huh. I know what's wrong. Do you see these types? These are not three-dimensional vectors. These are scalars. And of course, that's completely fine in HLSL. That's the one thing I hate about HLSL is the damn implicit casting of all the floating point values. There we go. We have a triangle. Ah, that took a while. Oh, I was so confused. Like, this code is exactly the same. Why is it? There we go. So now let's make the triangle a bit bigger. Oh, yeah, we can make it even bigger. We can make it just unit size. Cool. And then we can do this with a fraction and see what it looks like. Did our program crash again? Yeah, depth buffer. I should really fix that bug whenever we minimize it crashes. And then everything became yellow. Gives a bit of a funky look. Okay, so why is some stuff yellow? That's when t is 0. But it's not hitting. So why do you become yellow? What? It's always something stupid like that, that's the bug. Oh, now you're not yellow? Okay. You can definitely see the refraction effect going on. So let's turn all the other stuff on again. Now the reflection is gone. So we only do this if we hit. Let's just make it white. And if it doesn't hit refraction 0, let's do a full recompilation. I feel like a shader is not updating or something. Let's say if it doesn't hit, we will sample the skybox. And this is going to be our refraction rate of direction. This is basically our backup if it doesn't hit anything. Undeclared identifier. What is undeclared? Oh, semicolon. Oh, but that implicit casting, that one was really mean. Yeah, so now we're sort of refracting what is in there. What I'm thinking now is that we should like animate the water, but that means we have to do calculations of normals of the vertices again. What if it was a spinning triangle? I think we should definitely make the triangle spinning. But then I need to rotate things in shader code. Well, we don't have to. We can do it all in constant buffer. You know, multiplying things in a pixel shader really isn't the greatest. The greatest thing there is. I'm still laughing at this. Let's see, how will we... Is there like a quick and dirty rotate we can do? We can like angle is sine of... It's just... Yeah, just time, and then want sin angle sine of time of the angle. And then I want the cosine. Oh, wrong button. let's see, this should be cosine of the angle. And then I believe you do the following. You do cos angle times v0 dot x. This should be this like that. You want to assign it in one go, otherwise it breaks. Dot x times the cosine of the angle plus v0 dot z times the sine of the angle. Then we'll do v0 dot y. And then we do the same trick for z. But here we change the sine and the cosine. And then we do this for all three positions. And then we just need to pass the time, for which we need the constant buffer again. But if I remember correctly, we have a padding value. Yeah, that's perfect for passing the time. So let's first bind that buffer before I forget. There's actually a typo here. PS set constant buffers. We'll do, yeah, what a constant buffer. Then we go all the way up. Make it this time. I will we'll use the x offset that we used to calculate the rotation of the bunny. Because I don't actually pass the time to my render function. Oh no, we crashed. Why is that? Because you failed to load the shaders. The shader become too big again. The shader is too big again. Let's just make this buffer really big. So that's like a, how big? 256K buffer. Well, good thing you love the hack, because you know, sometimes you just want to get something working. It's really slowly rotating. Let's make it rotate a bit faster. That is a different offset. Okay, it's doing something I wasn't expecting. It's not rotating around the z-axis. What? What is going on? It looks really cool though. But it's not what I was expecting. Because I leave the y value in. Oh, because I'm only modifying the x value because implicit casting and everything. It looks cool. It's still doing something weird. Let's recompile. I really don't know why it's rotating like that. That's totally not what I was going for. Looks cool, but I would really like to have something that is correct. So for rotation of 0, this makes sense, right? Because this is going to be 1, this is going to be 0. For rotation of 90 degrees, this is going to be 0, this is going to be 1, so they swapped. Oh, because you need to negate one of these. And depending on which one you negate, the determines which way it's rotating. Yeah, now it's rotating correctly. We can see the reflection there. So now I'm wondering, can we do like a bunch of triangles? Um, that would be cool, right? So make a bool, any hit, set to false. I don't think my shader compiler is gonna like me here, or if even the graphics card is going to like me. But you know what? I don't really care. My compiler should just deal with this. And then we can do this. Like that. Just add the offset to each of these. Now let's, yeah, that's fine. And then if hit, we'll say if t if this t is less than t, because we want the nearest hit. If this t is less than t, for it to actually hit, so it's just an end here. We want to say t is this t. How would I do the bunny? Do you have to pass all this data into the shader? Technically, yes, you do have to pass all the data in shader. What we will be doing is we're going to use structured buffers to upload all the index buffer and the vertex buffer, so we can do random access on them. And what we'll also do is add an acceleration structure, so we can, instead of doing an ON algorithm, it becomes log n to ray trace. And then we can actually, in like 10, 15 steps, we can determine which triangle we hit. So we don't have to ray trace all the triangles for every ray. And actually, like, one of the reasons I wanted to do water with a shader is because there's this one really cool programmer that I follow on Twitter. I'm not sure if I'm going to be able to find his GitHub, but he basically did a. Perhaps if I look on this, hold on, I'm going to look up something on my other monitor. Yeah, and if I can I look. Let me look up something. So I think this was about. No, that's not it. Where is the thing I... It was somewhere on Twitter, and I'm looking at now. Yeah, this. So basically, regular bounding volume hierarchies use something called axis line bounding boxes. And what you'll do is you'll basically find geometry that's close together, put it in the bounding box, and then you find bounding boxes are close together, put those in the bounding box, so you get this hierarchy. So you first check, do I hit anything in the scene? Okay, if I hit anything in the scene, do I hit anything on the left side of the scene? Do I hit anything on the right side of the scene? And you go deeper and deeper and deeper. But he's talking about using axis-aligned bounding octahedra and a seven-sided AABB. So you can reject a lot of tests early on. And also encompass a lot of geometry a lot closer. And he did some tests with some A/B tests, and he got like way faster results, like twice as fast. So I was like, I want to try that on the GPU. Because with the GPU, loading something from memory is really slow, even though it's pretty good at hiding the latency. But if we don't have to hide the latency for a lot of tests, then that is awesome. Yeah, well, yeah, it is really awesome. So you create boxes like these around your objects, and then you can first just test with the first triangle around it. If that fails, we don't have to check the second one, but then we can still check the second one, so we get like a really close thing around it. Yeah, here you can see one triangle, two triangles, and that makes a shape like that. That's just super cool stuff. And I don't think it has been done on the GPU before. Yeah, and it actually uses slightly different axes, so it uses axes like these to get sort of the same result. Or this might be the seven-sided AABB. Basically, just add some diagonal so you can call it early on, so you don't have to load the second part of the the shape around it, and it doesn't trash your cache. So your cache can be used for more useful things. So yeah, that's the plan. But let's first get some triangles, like multiple triangles on screen with our simple linear algorithm, where we just check all the triangles. I'm actually thinking about it. We don't even care which one we hit as long as we hit anyone, since we just make it a color. But we'll just look through the whole thing for now. Yeah, that should give us a group of triangles. Yeah, it's working. The frame rate like completely tanks. We went from 1 millisecond frame to a 3 millisecond frame, but hey, you get more triangles. And it shows up the refraction. Although I'm still not sure if the refraction is correct. It might still be really wrong. You know, this doesn't seem realistic. Yeah, you also think something is off. No, I'm pretty sure actually that something is off. What I really want to try is try to take the reciprocal of this. Oh, that's not the reciprocal. Let's see if that changes it. Is that? I mean, that is also incorrect, I think, but in a different way. Does look cool though. I mean, we get the from refraction to reflection bit a bit more. Yeah, it seems more right, but it still seems wrong to me. But this just looks awesome with all the buildings in there. It looks like this is like some underwater plants, even though they aren't. I'm totally screenshotting this. Hell yeah. I also wonder, like, how far are these triangles underwater? Should I move them more down? What happens then? Yeah, they are pretty far underwater, so it doesn't seem right that they look like they're so up close. You see, because I moved them down a bunch more, but they barely move down in this. And there we have our bunny. He's a bit of an Easter egg now. This just looks really satisfying for some reason. Like it's really calm, relaxing water. It's totally water. Yeah, I totally agree. The Fresnel reflection does look awesome. What if those triangles were also mirrors? What? And then they can reflect into the water, then reflect from the triangle, reflect out of the water, and then also some reflection back into the water. We could go like as far as we want with this. Oh. Yeah, and here is space again. Well, exploding universe. But this time refracted exploding universe with some reflection. All because the normal is inverse. It's interesting how it still does the ray tracing correct though. And I really don't understand how it gets the broken colors. It's upside down. Yeah, because you're still looking at the bottom. This is like all the grassy stuff. But why does it get such broken colors? Oh, that might be Fresnel. Yeah, that's Fresnel. We're calculating incorrectly. From Stranger Things. Oh, I haven't seen Stranger Things. I think I like should totally watch it. I've heard there's Dungeons and Dragons in Stranger Things, and I'm like a big Dungeons and Dragons player. Big fan of D&D. What if we would take the absolute of the Fresnel factor? Would that fix the bug of the under of the upside down? No, that totally doesn't fix it. Or if you saturate it. Yeah, that just breaks the index now. It's pretty good. I've heard good and bad things about the D&D aspect. They kind of look it out of season 2. They kind of took it out of season 2. Oh, I should probably watch it sometime then. I heard though that there's some kid playing in it, and he's doing a new show where he's pranking people looking for a job, and that just seems so wrong. Like these are people trying to do their best to make it somewhere in life, and then you're gonna prank them? Like what the hell? That's just awful. That's the end of my Beer's Law. The things people do for views. Yeah, I know, right? I also want to look up the screen space reflections. So I sort of know how they work. Again, Unity. Unreal. Frostbite. Sigraph paper. I can do something with that. Rendering equation. Oh, they are doing like Monte Carlo screen space reflections. That's pretty crazy. That's not actually what I'm looking for. HLSL. I know the basics. You basically do ray marching on your depth buffer to figure out where your ray would hit. And the ray marching works by doing a binary search. So you basically check first some value. Did it go past the depth buffer? Then you move back like a quarter, and then if it isn't far enough, then you move forward by like an eighth, and you sort of close in. And then once you reach a point, you return that color. And you get weird stuff like that. Yeah, we should also totally do that at some point, but I'm not sure how well it mixes with forward shading, which we're currently doing. Perhaps we need deferred rendering for that. Though I'm not sure. Let's look at my to-do list. We did this, we did this, we did this, and we didn't do this. But I want to do that some other time. I've now been streaming for 6 hours, which is like the double I do usually. Usually it's 3-hour streams. Well, we got some extra stuff done. Like we did the Fresnel. We did reflection into skybox. We did refraction into skybox. Fraction on triangles. Yeah, with it. Yeah, we still need the screen space reflections. But I first want to add the BVHs, the BVH for model. Yeah, but so far I think it's really cool what we have. Although I'm still not sold on the refraction, whether that's going right or not. I just don't know really, to be honest. Yeah. I also want to add some waves, but then I have to calculate the normals, and I'm not sure how we're going to do that yet. Because then you need to read the neighboring vertices. Although you can calculate that. You can calculate the neighboring vertices. I actually wonder what the resolution currently is of the water effect. I have no clue. You can actually change the default rasterizer state for that. Fill line, I think it is. Fill wireframe. Oh, it is a really, really high resolution mesh. So high resolution that if you look at it from a distance, it's like it's not even a mesh, but only when you get close. This also looks pretty cool. I don't know, there's something about this that I like. Perhaps because we're just looking at the bunny again. He's a good boy. Or girl. We don't know. I think I'm gonna end the stream there, though. It's been 6 hours. It was a good day of streaming, though. And we have some cool stuff for next time. So next time we can build a what's it called? A bounding volume hierarchy. And we'll first build it with just simple axis line bounding boxes, and then build it with the axis lines bounding octahedron, or just first the seven-sided ABBs, and see how they perform. Perhaps we might even beat RTX, even though we're definitely not going to beat RTX because that's hardware ray tracing. I don't even have RTX on my graphics cards. All right. It was delightful to be programming with you guys again. And I'll see you next time. I hope to be. Oh, you can see my thing. I hope to be streaming somewhere this week, some evening again. That's probably gonna be a Wednesday evening, I think, for like just a couple of hours, because then I get home after work. So yeah, see you then. Bye bye.